Research YouTube channel. This is Dr. V. Chandra, Assistant Professor in the Department of ECE. Here we are going to talk about this course, Electromagnetic Theory and Interference. So in this course, particularly, we will see the two examples, the numerical examples on the rectangular waveguide and plane waveguide. So actually this question is very important. That's why I have selected only a few questions here for your reference. So in this question, let's see what are the parameters is given. The question is related to your rectangular waveguide. Having the dimensions A is equal to 2.5 centimeter, B is equal to 1 centimeter, and is to operate like this one, that is 15.1 gigahertz below to this frequencies. So now question is being asked that total how many TE and TM modes can the waveguide transmit if the guide is filled with a medium characterized by sigma equal to 0, epsilon naught is equal to 4 epsilon naught and mu r is equal to 1. So we have to also find out the cutoff frequency for these modes. So let's see how many modes will propagate. So if you remember, the cutoff frequency we can find using this formula. This is very much important formula. So always remember this, like f, that cutoff frequencies for any rectangular waveguides you can find using this formula, that is mu dash divided by 2 square root of m square by a square plus n square by b square. Now in the question already it is given A is equal to 2.5 and B is equal to 1 centimeter. So A by B you can find out that is equal to 2.1. 2.5. Also mu dash you can calculate, actually it is 1 divided by mu and epsilon naught, and mu is already given, that is mu is equal to mu naught into mu r, so that is 1, and epsilon naught is given, that is epsilon naught is equal to epsilon naught into epsilon naught r, so this is 4 epsilon naught. So in this manner put the values, mu is equal to 1, epsilon naught is equal to 4, you will get c by 2. So this is your speed of your wave. Now cutoff frequency, it's time to find out the cutoff frequency for this mode. So how can we find out? So formula, like just replace the values of mu dash that we have found here, and the remaining things like you can put the values of your m, like m and n leave right now, just put the values of a and b, and remaining things leave. So if you will solve, you will get f is equal to 3 square root of m square plus 6.25 n square. Question is that why are we not putting the values of m and n? So very simple, because m and n only will tell that how many modes will propagate. So we'll keep on putting the values of m and n from 0, 1, 2, 3 and onwards till the waveguide will carry the frequencies less than this. If frequencies will be higher than this, we'll stop to put the values. So now let's find how many modes will have the values of cutoff frequency less than this cutoff, right? Because in question itself it is given that the frequencies is operating below to this 15.1 gigahertz. So let's see how many modes will propagate. So option 1, first put the values of m is equal to 0, n is equal to 1. In that case your cutoff frequency you can put, you will get the value 7.5 gigahertz. So is this 7.5 point is lesser than 15.1? Of course yes, so it will propagate, right? Next, now put m is equal to 0, n is equal to 2, n is equal to 1 already put, we have already found the values. So now if we'll put, then we will get the values here, put the values m 0 and n is equal to 2, we'll get the values f cutoff is equal to 15 gigahertz. So is this less than this? Still yes, just because this is lesser than 15.1, so this will also propagate, correct? Now third one, now put the values m is equal to 0 and is equal to 3. Now check, fc is equal to value will be 22.5. Now is this lesser than this? Of course not. So will this mode will propagate? No, this mode will not propagate. So further we cannot go for higher values of n, because now it's time to stop. Okay, now next, Now we have already put the values of n. Now let's put the values of m. So m is equal to 1, n is equal to 0. In put the values, you will get f cutoff is 3. So is this less than 15.1? Yes. So this will propagate. Similarly, put the values of m, higher values of m, that is 2. Then you will get 9. So will this is this lesser than? Yes. 4, then you will get the value 12. Will it propagate? Yes. Then 5, it is 15. Will it propagate? Yes. Then 6, 18 gigahertz. So will it propagate? Answer is no. Why? Because this is greater than 15.1. So here how many modes will propagate? All these: TE 20, 30, 40, and 50. Now let's see some higher order modes. We have already put the values of n is equal to 0, 1, 2, 3, 4, and m is equal to 0, 1, 2, 3. Now put the values both. So 1, 1, so for 1, 1 f c11 is equal to 8.078. Is this less than 15.1? Answer is yes. So this will propagate. Now 2 m is equal to 2, n is equal to 1. So now if you'll put the values is 9.6. Is this less than 15.1? Yes. So it will also propagate. Similarly, TE31, that is m is equal to 3 and n is equal to 1. Now the final values is 11.72. Will it propagate? Yes. Similarly, 4, 1, m is equal to 4, n is equal to 1. So here 14.4. Will it propagate? Yes. Further, 1, 2 or 2, 1, if you'll put the values here, you will get like a 15.3, which is higher than 15.1. So further other modes will not propagate. So total how many modes will propagate? These two, the first TE0, 0, 1, then 0, 2, so 1 and 2, then here TE20, 30, 40, and 50. So 4 plus 2, 6, and here 1171213141. So here 4 more. So total your these modes will propagate, right? And correspondingly the correct cutoff frequencies. So these are the modes will propagate. So how many modes? You can count all these. So total values is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. Almost it will propagate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different values will propagate, 10, 11 values. Okay, so like that you can calculate the different cutoff frequencies for any rectangular waveguide dimensions. I hope this is clear. If you have any doubts, let me know. The most important thing is that you must know the formula to find out which frequency will propagate through the rectangular waveguide. So this is the formula. So this is the another question here. So a lossy dielectric has an intrinsic impedance of this one 200 an angle with this ohm at a particular frequency. If at that frequency the plane wave propagating through the dielectric has the magnetic field, this one magnetic field is given. What to find? You have to find the E and alpha. Right? Determine the skin depth also and the wave polarization. So first relation, what is the relation? E by h is equal to eta. So with the help of these equations, first we can find out the value of E naught. How can we find? So h naught is given here, and this is the relation eta, and eta is also given, right? So what is the value of eta? 200 angle of 30 degree. So with the help of this, we can get the value of E naught. So that is 2000 and a to the power j pi by 6. Why this is j pi by 6? This is your value. So just convert r theta is equal to sin theta plus j sin theta. With the help of that, you will get. Now, further, actually, our objective is to find out the E. That is, uh, the format, that is the how the wave will propagate. So except phase and amplitude, other things will be constant. So again, it will be the cos omega t, cosine only omega t, and so phase how much. So here already we have considered that is different by the pi by 6. So here that is why x by 2 and pi by 6, and that is the amplitude you can calculate using this one. Now what is the challenge? Challenge is to find out the value of alpha. So how can we find? So already beta is given, that is 1 by 2 here. This is your beta, that is 1 by 2, and put the values alpha. This is the most important equations that you should remember. Alpha is equal to omega square root of mu e by 2 square root of 1 plus so sigma divided by omega e whole square minus 1. Similarly for beta, now put the values and get the relation. So here alpha by beta equal to 1 by square root of 3. This is the relation. Now from with the help of the equation of the values of the beta, you can get the value of alpha, that will be 0.283. Also the skin depth can be calculated, is equal to 1 by alpha, that will be 3.4. So that's all in this session. Thank you for listening. If you have any doubts, please drop your comments.